All right, we are ready to begin Chapter 8. In Chapter 8, we'll deal with rational functions and rational relations. In Section 8.1, we're going to deal strictly with, we'll do some simplifying and then we'll do some multiplying and dividing. Multiplying and dividing rational expressions. Rational expressions, rational, you should associate the word rational with fractions. So we are dealing with fractions. They will be expressions, meaning they'll be in algebraic form. We'll have like variables in there, x's, that sort of thing. But before we do much with rational expressions, let's just think about fractions and some of the rules that you already know. Okay. What I'm going to do right now is not really what's in this section, but they're kind of follow the same rules. So let's consider simplifying. Let's go with 48 over, I don't know, 8. If I ask you to simplify 48 over 8, you're probably pretty good at that. I hope so. Actually, maybe I shouldn't use 8. That's going to work out a little too nicely. Let's go with sure. No, I don't want to do 12. Let's do 32. We'll do that. 48 over 32. We can do that. What would I do if I asked you to what would you do if I asked you to simplify 40 over 32? What's true about both 48 and 32? You can divide them by 16. Giving you 3 over 2, right? That's how we can simplify a fraction, because you can divide both the top and the bottom by the same thing. You're well aware of that, I hope. So, but let's see what that looks like in a rational expression. We could be given a problem like this: y squared plus 3y minus 40 over y squared minus 25. If I ask you to simplify that problem, what would you notice? Yeah, so what I'm going to do now, don't do, because it actually doesn't work, but I see it happen a lot, and I was hoping someone would give me this answer, that you might be tempted to see the y squared and y squared and think that you can cancel those out. In reality, you actually cannot. Because if I eliminate both of those, I didn't actually divide both the top and the bottom by y squared. Instead, what I did, if I eliminate just those terms, is I subtracted y squared from both the top and the bottom. You're not allowed to subtract something from the top and the bottom and still have an equivalent fraction. It doesn't work that way. So you can't divide it away unless you can divide it out of the entire thing. Look at the numerator, the entire numerator. Can you divide the entire numerator by y squared? No. To figure out what you can divide it by, it's easier if I write it in a different form. We know that division is the opposite of multiplication. If I could write the numerator and the denominator both as multiplication problems, that would be a lot easier. Well, we call that factoring. If you factor both the numerator and the denominator, they're written as multiplication problems, and it'll be much easier to see if we can divide the top and the bottom by the same thing. So let's do that. Let's factor the numerator. should get a positive 8 and a negative 5. If you factor the denominator, y plus 5 and y minus 5. Now they're written as multiplication problems. Is there something that you can divide away from both the numerator and the denominator? You can divide away, and I won't typically write this out in this way. I would rather just cancel them both out, but really what's happening is we're dividing both the top and the bottom by the same thing. And when you do that, that goes away, that goes away, and you're left with y plus 8 over y plus 5. So we've divided both the top and the bottom by something that they have in common, something they were both divisible by. Now look at what's left. Y plus 8 over y plus 5. Can I simplify that further? Getting rid of just the y would be like getting rid of just the y squared before. It really would just be subtraction. I can't subtract the same thing from the top and bottom. The only thing we're allowed to do is divide something out of both the entire numerator and denominator. Is there something you can divide the numerator by? You can't divide the numerator by y because there's no y in the 8 term, the second term. You have to be able to divide it out of every term. Y plus 8 is already factored all the way down. It is prime. That is a prime factor. Same thing with y plus 5. So y plus 8 is a thing. It's a factor. Y plus 5 is a factor. They can't go further. Do they have a common factor? They don't. Y plus 8 is different than y plus 5. So that is as simplified as we can go. All right, let's go. Let's jump to multiplication now. There's some simplifying. What about multiply? Let's go back to something we've done for years. Before 15th times 25 over 8. If you were asked to multiply those together, how do you multiply fractions? You can multiply straight across. In which case your numerator would be 100 and your denominator would be 120. And then we would have to do what? Simplify them. What can you divide them both by? 10. We can divide them both by 10. Is that enough? We can divide by both of those by 2. 5 over 6. So really I could have divided them both by 20. So 5, 6 is our answer. Now, there is another way that we could, another order we could have done that. Instead of multiplying first and then simplify, is it possible to simplify first and then multiply? It is, and the advantage to simplifying before you multiply is that when you look at the original problem, we're dealing with smaller numbers. Sometimes dealing with smaller numbers makes it a little bit easier. So as you look at the original problem, when it was written in fraction form, what maybe do you notice? Yeah. you can divide 15 by 5, but you can't multiply it. You can't divide 4 by 5. What can you do though? If you can divide 25 by 5 and 15 by 5, you're welcome to do that. Why? Well, because we know that the 25 and the 4 are both going to be multiplied into the same numerator anyway, and the 15 and 8 are going to be in the same numerator anyway. You can simplify across fractions as long as it's multiplication. So additionally, besides the 15 and the 25, we can also simplify the 4 and the 8, yeah? Divide both by 4. And so now, 1 times 5 is 5, 3 times 2 is 6. Then we get the same answer. Did it matter which way we did it? No, it really didn't. But, and as we get into today's section, sometimes I think it's advantageous to simplify first. Sometimes I think that's a little bit easier. So what might this type of problem look like in today's section? Well, it could look like a couple different things. Take a look at this problem. If you look at each numerator and denominator, you'll notice there are no pluses and minuses like there were in the problem I did up above it on the simplify. That means I don't have to factor this. It's already in factored form. It's already all multiplication. So it's a little bit easier. I can jump right into simplifying. Once again, you can choose to simplify first and then multiply, or if you would rather multiply, you can multiply your 12 times your 14. You can multiply your 21 times 8. You just get big numbers at that point. I would like to simplify first. So as I see 12 and 21, I notice that they're both divisible by 3, giving us a 4 and a 7. Look at 14 and 8. They're both divisible by 2, giving us 7 and 4. Can I simplify those coefficients? I'm just looking at coefficients. Can I simplify them anymore? Yeah, because my new 4 up here and this 4 down here could both cancel each other out, leaving just ones. And this 7 and that 7 can cancel each other out, leaving just ones. So all of our coefficients actually cancel out. What about variables? Do I have any variables that can simplify? C, I heard C first. How many C's can we cancel out? 2. We can cancel out both of the C's from the denominator. When I cancel out 2 C's from the numerator, how many are left? 1. So that's now like C to the first, or just C. What about D's? I can cancel out 1D. The D from the denominator goes away. I'm left with 1D up there. What about A's? How many can I cancel? Cancel 1A from the bottom, leaving me with 1A in the top. Can I cancel any B's? Yeah, there's 1B in the top and the bottom, so they both cancel out. There's no more B's left. So what is my answer? Well, what's left in the numerator? A C, a D, and an A. I'm going to put them in alphabetical order. A, C, D, none of them have an exponent. What's in the denominator? Just a 1 or just nothing, so I don't have to write it as a fraction. So ACD. What happens if I have a multiplication problem, though, with addition and subtraction in it? So we have a multiplication problem here. I can't just start hacking away and canceling things out because there's addition and subtractions in there. So it's not written in factor form. So what do we need to do? Factor. Factor first. Okay, in that first numerator, 8x minus 20. If I factor that, I would recognize that they're both divisible by 4. I would factor 4 out of both terms. 8x divided by 4 is 2x. Negative 20 divided by 4 is negative 5. So I end up with this numerator. in the first denominator. It's a quadratic. Two numbers that multiply to negative 35 that add to 2 are positive 7 and negative 5. So there's the first fraction. Now let's factor the second fraction. The numerator is a quadratic. Two numbers which multiply to positive 10 add to negative 7 would be negative 2 and negative 5. And in that the second denominator, it's actually two things that are going to have to happen first. We should factor out the 4, which then leaves us with x squared minus 4, but x squared minus 4 factors down further. Goes to x plus 2 and x minus 2. Okay, so factoring is done. Now we can start hacking away. I heard x minus 2. We have an x minus 2 in a numerator and a denominator. They happen to be in the same fraction. That's unimportant. I hear x minus 5. We have an x minus 5 that's in a denominator and a numerator. That goes away. The 4. We have a coefficient of 4. I can divide them both by 4, so they go away. Is there anything left? Anything else I can cancel, rather? It's a multiplication problem, so it wouldn't be. There are no other common factors. So all that's left in the numerator is a factor of 2x minus 5. In the denominator, I have two factors. So I use parentheses around them, x plus 7 and x plus 2. There is no need to multiply that denominator out. We like factored form. Factored form is usually preferred in many cases. So do not bother multiplying that together. That would be a waste of time. I wouldn't bother with it. And there's our answer. The last piece of this section is division. And similar to the last couple things, let's start with a division problem, a fraction division problem that you're more familiar with, and then we'll move into expressions. Three eighths divided by 27/16. Here you will notice that we're dividing by a fraction. We don't really like dividing by fractions. We prefer to think of it as a multiplication problem. We can multiply, we can turn it into a multiplication problem as long as you reciprocate the fraction that came after the division. Some of you learned some different sayings probably at some point in your math career, like leave change change or leave flip flip, or I don't know, some other variations I've heard students say. But ultimately, we're going to switch it from a division sign to a multiplication sign and reciprocate the second fraction. And now it's just a multiplication problem, like what we just did. Is there any simplifying we can do? Well, the 3 and the 27 can simplify. 1 and 9. Additionally, the 16 and the 8 can simplify. And now you can multiply straight across. 2 over 9. So, what might that look like in this section? go with 12x to the fourth, y to the second, over 40, a to the fourth, b to the fourth, divided by 6x to the second, y to the fourth, over 16, a to the second, x. Can we simplify first? If you want to simplify within a single fraction, you may, but aside from that, I would recommend probably just switching it to a multiplication problem first. I think you'll get into less trouble if you just switch it to multiplication before you do anything else. So multiplication, but it's the reciprocal of the next fraction. And now, if you want to multiply straight across, you can, and simplify later, or you can simplify right now and multiply later. Maybe what jumps out to me is the 12 and the 6. I can get rid of that entire 6 in one step. I can get rid of the 2 if I make the 40 a 20. And then 16 and 20, I can divide both of those by 4. Okay, now we could have done the coefficients in a different order, but ultimately we should end up in the numerator with a 4 when I multiply them together, and then the denominator should end up with a 5. So it'll be a 4 over 5. We know that part. What else can we cancel out? Let's look at A's. I can cancel out 2 A's, it looks like. There were 2 A's in a numerator, leaves me with 2 A's in a denominator. B's, can we cancel any B's? No. There were only B's in the denominator, there were none in the numerator, so the B gets to stay there. X's, what about X's? How many X's total do we have in the numerator? There's actually 5, because we have 1 over in the second fraction, 4 in the first fraction. So we actually have 5 X's in the numerator. And how many in the denominator? 2. So we can get rid of 2. I'm trying to get to my purple. Okay, there we go. And get rid of 2 X's. And then 2 X's from the numerator. Maybe I'll take out that single one. And then 1 more from over here. So there's actually 3 X's left in the numerator. And then what about Y's? 2 Y's I can get rid of. Both Y's from the numerator leaves me with 2 in the denominator. So there's our answer. But the trickier ones, in my opinion, are when we have the plus and minuses in there. So let's do another division one. And I'm going to write it in a little different form as well for fun. Let's go with x squared minus y squared over y squared minus 49 over y minus x over y plus 7. We would call this a complex fraction. There's a fraction inside of a fraction. It's a complex fraction. So what I might be tempted to do first is make it not a complex fraction. Make sure you understand that those mean the same thing. And now I can turn it into a multiplication problem. So turn it into a multiplication problem, reciprocated the second fraction, and then we should make sure everything is factored. So the first numerator goes to x plus y, x minus y. The first denominator, y plus 7, y minus 7. The second fraction, the numerator y plus 7, it doesn't factor. It is a factor. And the denominator y minus x, well, I could write it as y minus x, but what else could I do with y minus x? Everything else, I mean, I have other terms with x's and y's in them, but they're written with the x value first. I'm going to rewrite y minus x even right here. How can I write that? Negative x plus y. The x was the negative one, not the y. So I would want to factor the negative out of that because I want my x to be positive. So factor a negative out, and then it changes the sign of the y also. It ends up being negative x minus y. Okay, now we can start canceling if possible. Y plus 7s, you might see. I see x minus y. And that's all. Don't forget about that negative, though, that's out front. Oftentimes, we don't like to leave negatives in the denominator, so oftentimes what we do is just move it in front of the fraction. I'm going to take that negative here and just slide it in front of the fraction, and then in the denominator I have y minus 7, in the numerator I have x plus y. Sometimes we take that negative and distribute it to the numerator. You could do that as well. I'll just leave it like this. So it's a negative x plus y over y minus 7. We just don't like negative denominators. If you think about like when we had to rationalize fractions, I mean, we're very particular about what denominators are. We want denominators to be a positive integer. Now this one can't be an integer, it's an expression, but that's why we don't like the negative hanging out down there. But if you think about like, I don't know, let's say 5, and my stylus isn't going to work, but if you think about like 5 divided by negative 2, maybe let's go say 6 divided by negative 2 is negative 3. Well, that's the same thing as just saying negative 6 divided by 2, or negative 6 divided by 2. We just don't like negatives in the denominator. We're pretty protective about what our denominator is. So the accepted way would be just to move the negative out front or distribute it to the numerator. Okay, that is the end of the notes for today. That's the multiplying and dividing. Tomorrow we get into adding and subtracting, and when you add and subtract fractions, you have to have a common denominator. So adding, typically addition and subtraction seems easier in multiplication division, but not when it comes to fractions. Yeah? This is the first unit. So this will be on the test.